Hello and welcome to a very short session about an upcoming exciting global connection pool feature for Pgpool-II. This is about me. My name is Mohammed Usama. I'm a senior software engineer at Percona and I'm associated with Postgres since 2007. I'm also a major contributor and committer of Pgpool-II project, and I've contributed many features to Pgpool-II, including Watchdog, dynamic spare process management, consensus and quorum-based backend failover. And currently I'm working on this exciting new global connection pool feature. That is actually a topic of this presentation as well. So let's start with why connection pooling is important, especially for the Postgres. First and the foremost thing is, as we already know, like Postgres does not like large number of concurrent connections. As we start to increase the maximum allowed connection limit on Postgres side, its performance starts to suffer. And when our application requires to make a large number of backend or database connections, introducing a pooler between database and application really helps in getting better performance. And on top of it, pooler actually minimize the latency introduced by connection establishment. That leads to a faster response of user request, and it also optimizes the resource utilization by reusing the existing connection. And I think for a typical OLTP environment where the connections are short-lived, and what application does is it creates a database connection, issues a transaction, and disconnects it and repeats this process over and over and over again. In these kind of workload environments, Pooler can really help you gain the performance on the database server. So let's now discuss how Pgpool-II connection pooling works. And these are some of the key concepts of connection pooling in Pgpool-II. As we know, Pgpool-II also uses a multi-process architecture, just like similar to Postgres. And just like Postgres, each child process handles one client connection at any time. And another important aspect of Pgpool-II that needs to be kept in mind is each child process maintains its own connection cache. So if you have 100 child processes in Pgpool-II, effectively you have 100 small connection caches within Pgpool-II. And each connection cache will be utilized by one client at any particular time, and only one entry of this connection cache can be utilized at any time. And no matter how many connection cache entries you have in one child process, only one can be used at any time. And hitting an existing cached connection by a new connection is totally a random chance. Like if your child process is caching a connection for user one, DB1, and a new connection comes in that is for user 2, DB2, it's by a chance. Like if you hit the same child process which has the connection cache entry for this the same database and user pair, then it's a connection then it's a cache hit. But if the operating system kernel selects some other child process which have a connection cached for a different username database pair, then you have to recreate a new connection. So it's kind of a random process. And there's not, like Pgpool-II cannot have much control on this one. And there are two very important configuration parameters around connection cache. One is nominate children. That sets the limit on maximum concurrent connections Pgpool-II can support. So if you want to support 100 concurrent client connection, that means you need to set nominate children to minimum 200. You can set a higher value, but yeah. The second configuration parameter is max pools. Max pool actually sets the limit on how many connections can be cached by a single child process. So if you want to calculate the total required backend or a Postgres connections on a server side, you can do it by multiplying max pools by nominate children. So if the nominate children was 100, max pool was 2, that means you need at least 200 connections on the Postgres side. Okay, to understand this concept in bit more detail and to see what are the problems with this particular architecture of connection pooling, let's consider a typical deployment, typical Postgres deployment with the Pgpool-II. In fact, a small deployment like most production environment are on a bigger scale than what we are discussing right here. So let's consider we have 3 Postgres servers configured in a streaming replication mode, 1 primary and 2 standby servers. And we want to implement high availability, load balancing, and query caching. So only one single software comes into our mind, that is Pgpool-II, that provides all these functionalities. And if we look at the documentation of Pgpool-II, we came to know like it also provides the connection cache. So why don't we also enable the connection cache as well? Because we are already installing Pgpool-II between our server and client. So let's enable the connection cache as well. So we did the same. So this is how the Pgpool-II will look like. Okay, on top of it, so our application in a maximum load situation issues 100 concurrent database connection. So to support 100 concurrent connection, we set num init children value to 100 in pgpool.conf as we discussed earlier. So second thing we want to decide is what should be the max pool value for our deployment. So we have three distinct database users and 3 distinct database on our Postgres side. So we can set max pool to 9, like multiply number of users by number of databases. 3 into 3 is equal to 9. So we can set max pool is equal to 9. But I don't want such a huge number. So to be on a lower side, so that my Pgpool-II system can consume should not consume a huge number of resources. I decided, or the database administrator decided to go with max pool values is equal to 3. He cannot actually change the num-init children value because he needs to support 100 client connection at any time. So he kept the num-init children value to 100, but he sets the max pool value to 3. So that means the each child process will cache three client or 3 backend connections within itself. And okay, so because Pgpool needs to provide the load balance, so it actually creates a connection. Each cache entry actually consists of 3 backend connections, one for each server, one for primary, one for standby 1, and one for standby 3. So one client connection in Pgpool-II means three backend connections in this case. If you increase the number of servers, that means the number of connections per cache entry will also increase with it. So so this is how Pgpool-II internal caching system works. So now I want to calculate what should I set the max connection value on the Postgres side. So I have num-init children is equal to 100 and max pool is equal to 3. And as we discussed in the previous slide, to calculate the maximum number of connections on the Postgres side, we need to multiply num-init children with max pool. So if we multiply 100 by 3, the results comes out to 300. So we will set 300 on the Postgres side for max allowed connection limit. So if we go back and think like the setting 300 on the Postgres side actually contradicts our own statement. In the first slide, we said that the base requirement for using the pooler in Postgres environment is we want to decrease the maximum connection limit on Postgres side, because increasing the connection limit on Postgres side actually degrades the performance. But with Pgpool-II, even our application actually all wanted only 100 connection, but to support 100 concurrent connection, we had to set 300 on the Postgres side, which is not optimal, which actually is contrary to what we wanted from connection pooler. We actually wanted connection pooler to reduce our requirement of allowed connections or a maximum connection on Postgres side. But unfortunately, Pgpool-II has increased the requirement from Postgres sides rather than decreasing it. So this is one big problem with Pgpool connection pool. So if we shortlist all the shortcomings of current architecture of Pgpool-II connection pooling, we can say that one of the problem is it wastes lots of backend connection because of its architecture of keeping a localized connection cache for each child process. The second problem is it only supports session level connection pooling. Like there's no concept of transaction level connection pooling and other connection pooling modes. And again, the hitting a connection cache or missing a connection cache is a mere random chance. Like you cannot control it. And similarly, there's no possibility to implement a pre-warm cache with current localized connection cache design. And last, it does not provide any control to limit pool size for particular user database pair or anything. So overall, if we see like the current architecture of connection pooling does not serve our purpose. It has increased the requirement on the Postgres side. It is wasting the connections, and so it's suboptimal. So that's why the community is thinking of changing the connection pooling architecture in Pgpool-II and bringing in the global connection pool, which we are going to discuss now. So now this is the difference. Previously, each child process used to have its own localized cache. Now the connection cache has been made global. Now, now the responsibility of maintaining the backend connection is taken away from the child process and it is given to a Pgpool main process. So that is a parent process of all the child processes. Now the main process maintains the pool of connections and child process only borrows it when it is required. So okay, so now what that means? That means nominate children is independent of number of backend connection. So even if you want to support 100 concurrent connection, that does not mean you need 100 into max pool size of connection on the backend side on a Postgres server side. So even if you set nominate children to 100, you can set max pool size to 30. That means I only want 30 connections on the Postgres backend side, but I also want 100 concurrent connections from the application side. And this is possible with the global connection pool. So each Postgres server will only have pool size number of user connections from Postgres. If you set pool size to 20, that means that each Postgres server will get maximum of 20 connections from Pgpool. That's it. So this actually serves the purpose. The very first requirement we discussed from that the pooler should reduce the requirement from the database connection requirement from the database side rather than increasing it. So this is what happens when a new child process a client connection comes to Pgpool-II, and then a child process borrows a client connection from a global connection pool, database client connection. So like shown in the figure, the new connection was for user 1 DB2. So the child 3 searches the user 1 DB2 pair in the global connection pool, and if it is able to find the same username database pair cached in the global connection pool, that connection will be borrowed by the child 3, and then that connection will be used to serve the client application, and that connection will be marked as busy on the or in use in the global connection cache, so that if another child asked for a connection, this connection should not be shared by the client unless this is released by the current child process. So what happens when the client disconnects from Pgpool-II, the connection is returned back to the global connection pool, and that connection can be reused by another child process for a next client connection. So this is how it works. So if we see what are the advantages we can get by implementing a global connection pool in Pgpool-II, the first and the foremost is it decreases the requirement of number of backend connections from the Postgres side, which is a big win. And the second is there will be no connection backend connection wastage. Previously, because each child process was having its own connection cache, so only one was used at any time, and all the rest were being wasted. And with this global connection pool, there's no wastage of backend connections, and again the connection reusability is better with this global connection pool. And on top of it, we use, because now the child process and connection pool are separate, so we can also implement the transaction connection pooling along with the session connection pooling, and we can also implement the pre-warm connection pooling with Pgpool-II. You can set create 100 connections of user 1 DB1 at the start of Pgpool-II. That means like the initial response will be vastly improved with connection pre-warm connection pool mechanism. And this will also give you more control on pool size for each database user pair, which is not present at the moment. So about the current state of global connection pool implementation, the infrastructure is already completely implemented. The session level connection pooling is working, and now what is remaining is some stability, some testing is remaining, and then some code cleanup is remaining, and we are trying to finish it before the next major version release. And you can I've pasted the GitHub link for work in progress code, and you can go there, and you are welcome to contribute, to help in testing it, to contribute with the code, with testing, with finding bugs, and so that's all about global connection pool, which you can expect in the next major version of Pgpool-II. And that brings me to the end of my presentation. I've taken more time than I actually promised, and thank you very much for listening, and arigato. Thank you. Bye-bye.